Okay, in this video we're going to solve trigonometric equations. As you can see in the directions, we're going to solve over the interval 0 to 2 pi. This means all of our possible answers could come from all four quadrants of the unit circle. Now let's look at example 1. The cosine of theta equals -1/2. So this is a very basic example, but the way we want to approach all of these equations is we want to treat the cosine of theta or the sine of theta, tangent theta, whichever one is in our equation. We treat it like we would treat an x when we're solving a regular algebraic equation. We want to get it in the form x equals a number. In this case, we want to start by trying to get cosine of theta equals a number. Then once we get there, we can try to find the theta that makes the equation true. So for example 1, we have the cosine of theta equals -1/2. So our goal is to try to find what values of theta would work that give us the cosine of -1/2. So since we're dealing with all four quadrants, we need to ask ourselves, where is the cosine negative? It equals -1/2. And we know with our all students take calculus, cosine is negative. Well, from this, cosine is positive in the first, right, and fourth quadrant. Therefore, we know that cosine is negative in the second and the third quadrant. So we know that we have to have angles from quadrant 2 and quadrant 3. And so what we can do is I added this chart, the chart that I like to teach by, that's just a reference angle chart that's helpful. And we can come over here and say, well, where's cosine 1/2? So we come over here, let's see, cosine is 1/2 at pi over 3. So my reference angle is pi over 3, but we're looking for -1/2. So remember, we need a quadrant 2 angle. So for quadrant 2, if we're dealing with pi over 3, remember in quadrant 2, that would be 2 pi over 3. And for quadrant 3, that would be 4 pi over 3. Remember, quadrant 2, the numerator is 1 less than the denominator. And for quadrant 3, it's 1 more than the denominator. So my two values of theta that work are 2 pi over 3 and 4 pi over 3. Now let's look at number 2. So for this, our first step is we want to get this in the form of sine of theta equals a number. So treat sine of theta like we would treat an x. So my first step is let's bring the square root of 2. We'll subtract it to the other side, get negative square root of 2. Then we want sine of theta by itself, so we can divide out by 2 both sides. That gives me the sine of theta equals negative square root of 2 over 2, and this is what we're wanting to solve. Okay, so similar to the first one, our sine equals negative square root of 2 over 2, so we need to ask ourselves, what quadrants would theta be in? So we know with all students take calculus, sine is positive in the first and second, and it's negative in the third and fourth. And since my value is negative square root of 2 over 2, we know that my thetas are going to be angles that exist in quadrant 3 and quadrant 4. So we just need to go over to our chart up here in the upper right corner. Where is sine square root of 2 over 2? So sine is square root of 2 over 2 at pi over 4. That's my reference angle. So for a quadrant 3 angle, using pi over 4 as my reference angle, quadrant 3, remember it's 1 more in the numerator, so 5 pi over 4. And for quadrant 4, remember our little trick on this, you can double the denominator and get 8 and take away 1, 7 pi over 4. So these are my two angles, my two values for theta that solve the equation. Okay, for number 3, our goal is to get cosecant of theta by itself on one side. So let's start by adding 2 to the other side, and then we can divide out by the square root of 3. Here we go. That gives me cosecant of theta equals 2 over square root of 3. Okay, so now we need to find the value of theta. So we have cosecant. So I'm going to change this because I know the reciprocal of cosecant is sine. So we can rewrite that sine of theta and we can flip it. All right, it's square root of 3 over 2. This is easier for us to solve. So in this case, square root of 3 over 2 is positive. So we know that sine is positive in the first and second quadrants. we have first and second. So my angles for my answer, I know I have to have an angle from, let's see, quadrant 1 and quadrant 2, because those are the two quadrants that give me positive sine. So let's look at our chart. Sine of square root of 3 over 2, let's see, happens at pi over 3. My reference angle is pi over 3. So for quadrant 1, that's just the reference angle, pi over 3. And for quadrant 2, remember we use pi over 3, but we can rewrite it as 2 pi over 3. These are my two answers that work. And so this is my solution. Okay, for number 4, if you notice we have two things being multiplied that equal 0. So like we normally do with solving equations, we know that we can set each of the factors equal to 0 and solve. So I'm going to set the sine of x plus 1 equals 0. And I'll set 2 cosine of x minus 1 equal to 0. So we just solve both of these, and our answers all together will be my solution for the problem. So let's first look at the sine of x plus 1. We want to get sine of x by itself, so let's subtract 1 to the other side. So we are looking for what x gives me the sine of x equals negative 1. Well, if you look over at our chart, you notice sine is 1 at pi over 2. So this angle will fall somewhere on the xy axis. So let's think about this. I like to draw, if you remember, our little unit circle here. And if you draw each point, we know this is the point 1, 0, right? We get 0, 1 up at pi over 2. At pi, we get negative 1, 0. And down at 3 pi over 2, we get 0, negative 1. Now, if you remember, for these points, the first value is always cosine, the second is sine. So if we look, where is sine? Negative 1. It happens right down here at 3 pi over 2, and it's the only place that it happens, because at pi over 2, we have positive 1. So for this, there's only one solution for the sine of x. Where does it equal negative 1? And that happens at 3 pi over 2. Okay, so that solves the first part. Now let's move over here and solve the second part. So we want to get cosine of x by itself, so let's add 1, and we can divide by 2. So we have the cosine of x equals 1/2. Let's figure that out. So cosine equals positive 1/2. So we know all students take calculus that cosine is positive in the first and fourth quadrant. So here we have two possible angles, one from quadrant 1 and one from quadrant 4. So let's look at our chart. Where does cosine equal to 1/2? We have it right here. That happens at pi over 3. So my quadrant 1 angle would be pi over 3, just my reference angle. And for quadrant 4, if we write it in terms of pi over 3, remember our trick. You can double the denominator and get 6. Take away 1. 5 pi over 3. Okay, so my answer for the whole problem, we're going to put both of these together. All right, so my final answer is we have 3 possibilities: 3 pi over 2, pi over 3, and 5 pi over 3. This is my solution. Okay, for number 5, if you notice, we have a cosine squared and a cosine of theta. So remember, we treat the cosine of theta like we would treat an x in a normal equation. So when I see this, I look and go, okay, can I factor? Yes, I can factor. I look at, and I have a cosine of theta. So I can factor out a cosine of theta from the problem. When I do that, I'm left with 2 cosine of theta in the first part, plus, and then I have a square root of 3. So I just factored it basically, and now I have 2 factors. We set each factor equal to 0 and solve. So the first one, we're going to solve where's the cosine of theta equal to 0. And the second part, 2 cosine of theta, theta, plus square root of 3. Where is that equal to 0? So let's solve each one of those solutions we can put together for our final solution. So where's the cosine of theta equal to 0? We can look over here, and cosine is 0 at pi over 2. So we do need to think about it because this theta would rest somewhere on the xy axis. Okay, I've drawn my circle, my unit circle, and if you notice, the cosine is 0 in two places. We have pi over 2, because cosine is cosine is 0, and 3 pi over 2. So two possibilities for theta here, pi over 2 and 3 pi over 2. All right, so now let's look at the second part. We need to solve 2 cosine of theta. And my plus square root of 3 equals 0, so let's subtract square root of 3 over to the other side, and we can divide by 2. That leaves us with cosine of theta equals negative square root of 3 over 2. And it's negative, so remember, where is cosine negative? All students take calculus. Cosine's positive in the first and fourth, therefore it is negative in second and third. So for theta, we need two angles. Where is it negative? We have a quadrant 2 angle and a quadrant 3 angle. So let's find our reference angle. Let's come over to our chart. Where's cosine square root of 3 over 2? Happens right here at pi over 6. So pi over 6 is my reference angle, but for quadrant 2, we would write that as 5 pi over 6. And for quadrant 3, that would be 7 pi over 6. And our final answer would be all four of these. You would list them all together. Okay, for number 6, this one looks a little different. We have a cosine and a sine. So the way we can approach this is, I can divide both sides of an equation by anything that I want to, as long as I do it to both sides. So I'm going to divide, both sides by cosine. On both sides, cosine of theta. That gives me cosine and cosine. That leaves me 9 on one side, and then negative 9. And we know that sine over cosine is the same thing as tangent of theta. Okay, so this puts it a little bit easier for us. We want to get tangent of theta by itself, so we can divide out by negative 9 on both sides. That gives us negative 1. These cross out. Negative 1 equals tangent of theta. Now we can solve it. We want to ask ourselves, where is tangent negative? We know tangent, is positive in first and third. So tangent is negative in second and fourth. Right? So my theta, I need to have a quadrant 2 and a quadrant 4 angle. So let's come over and see where is tangent 1. Tangent is 1 right here at pi over 4. That's our reference angle. Since we're looking for negative, we need quadrant 2. So if pi over 4 is our reference angle, in quadrant 2 we would write that as 3 pi over 4. Remember, 1 less in the top than the bottom. For quadrant 4, you can double the denominator, get 8, and take away 1. That'd be 7 pi over 4. We have two possible angles, 3 pi over 4 and 7 pi over 4. Okay, let's look at number 7. We have the tangent squared of beta equals 1/3. And just like in a normal algebraic equation, when we have x squared, we can use the square root property and take the square root of both sides. So let's take the square root of tangent squared. So if we do that, the square root of tangent squared of beta, right, we have to take both sides. That's the square root property. And when we do that, we have to include plus and minus the possibilities. So when we take the square root of squared, that leaves us tangent of beta on one side. And on this side, we have the square root of 1 over the square root of 3, which is plus and minus 1 over the square root of 3. So now we have two possible equations. First, we have the tangent of beta equals positive 1 over square root of 3, and the tangent of beta equals negative 1 over square root of 3. So let's look at the first one. Now, where is tangent positive? We know if we do our all students take calculus, the tangent's positive in the first and third, and negative in the second and fourth. So let's look at the first one. Where's the tangent? Positive 1 over square root of 3. So if we come to our chart, tangent is 1 over the square root of 3, right here at pi over 6. And it's positive, in the quadrant 1 and quadrant 3. So if our reference angle is pi over 6, our quadrant 1 angle is just pi over 6. It's just the reference angle. And then pi over 3, that would be 7 pi over 6. Now let's look at the second one. Where's the tangent? Negative 1 over square root of 3. We're going to use the same reference angle but it's negative in the second quadrant and the fourth quadrant. So we need a quad 2 angle. We have the same reference angle, which is pi over 6. But quadrant 2, we'd write that as 5 pi over 6. And quadrant 4, if you remember, we can double the 6, take away 1, so that's 11 pi over 6. So these 4 angles are the solution to my problem. Okay, for our last example, this one's kind of a little different. If you notice, we don't really have a theta. Our theta here is written as x plus pi over 6. And we want to solve for x, but we're going to treat x plus pi over 6 as our theta. So to start, let's get it where we have cosine by itself. Over here, plus pi over 6. Let's subtract 1 to the other side, and we will get equal to negative 1. Now remember, we're treating x plus pi over 6 like a theta. So it's like the cosine of theta. Where does it equal negative 1? So I've drawn my unit circle, drawing here where we have our points on the xy axis. And if you notice, the cosine is negative 1 right here at pi. So we can say that the cosine of theta equals negative 1 at pi. But once again, we really don't have a theta in the problem. Our theta, let's go ahead and rewrite that as x plus pi over 6. And we're saying that that should equal pi. Now we can solve this for x. Let's do it over here. So I'm going to solve for x. So why don't we subtract pi over 6 to the other side of the equation. And let's convert pi to a common denominator. Pi is the same as 6 pi over 6. So that gives me 6 pi minus pi over 6. That gives me 5 pi over 6. My answer is x equals 5 pi over 6.